He's got a fever, and my parents have meetings, so I have to take him to the doctor's, and I have to leave in 25 minutes.
Okay. All right. Well, you'll get the most of the gist of it, and you can catch the rest on YouTube.
Oh yeah.
Okay. All right. Let's see.
Sir, you're such a kind guy.
All right. Recording's on. Welcome to H period Algebra 2. It's Tuesday, April 27th, and here we go. A couple things, a couple announcements. Last Thursday, you had a 5-2 quiz and a 5-3 problem set. Okay, a 6-4 problem set. 5-2 quiz and a 6-4 problem set. And Mr. Daughtry, Mr. Jackson, and Mr. Curzon were the first to submit, which is good, but I'm still missing quizzes from Woolfolk, Valise, Porterfield, Neighbors.
What the?
Victor Johnson, Aiden Johnson, Brandon Jenkins, Henry Guire, Reese Griffin, and Miles Bunch.
Lizzie Gaffney.
If you want to get something other than a 0 on that quiz, I need it today. All right?
What do we think?
Have my quiz.
Hold on a second. I'm inundated with teaching 6 classes now and 80-some students, and I need the stuff when it's due. So it was actually due last Friday. So get those quizzes in today, otherwise it's a 0. I'm not going to go take it tomorrow morning and take it late. So if you want that quiz, if you want to not have it be your drop 0, then you need to get that to me today.
Sir,
And I'd rather you email it to me, because to go back into Dropbox and figure out whose I have and who I don't have, that too is kind of a maintenance nightmare.
which quiz was it?
It is the quiz that we prepped you for, and I put online, 5-2 quiz.
Okay.
What's the highest grade we can get on it?
Wait, did I turn it in?
Carpin, you turned it in late. Yes, I've got it now.
All right.
So what's the highest grade we can get on it?
100. I believe it's 108. I believe. I think it's there.
Word. I'll turn it in right now.
I think it's 108.
I'll shoot you an email right now, sir.
Okay. All right. So, any questions on that? Any questions on the quiz? All right. Any questions on anything else related before we jump into the lesson? Okay. So, I'm gonna share my screen and put up 6-4 number 1. And kind of talk you through and re-highlight the make sure ofs, watch out for us, be careful ofs, remember 2 kind of things. And then I'm going to start 6-4 number 2, problem set 2 with you guys today. We'll do a handful of those. I've already loaded it up Blackboard. I did not put a Dropbox for it. I do not want to see it. Okay, it's for you to do and practice. And like I said, I'll get you up to speed on that one today, and then on Thursday we'll kind of go over that one, wrap it up. You'll take a quiz on it, and then we're going to move on to section 6-5, which is more of the same stuff with radicals and exponents and all those good kind of things. So that's the plan. Any questions before we get firing away? All right.
Let's get after it, sir.
Do it.
Let's get a little freaky
Let's
today.
get to it, sir.
Let's get weird, sir.
All right. So you should have this problem set there on your desk or there.
That was easy money.
So I'm gonna run through these fairly rapid pace, and then just if something doesn't sound true or accurate, or you're like, where did that come from? Politely and diplomatically, just stop me, and I'll go into more detail.
Did we have to turn this one in? So,
Yes, cheese.
oh, I forgot to turn it in. Sorry.
Okay, so here we go.
Dope.
We're simplifying under the radical. All right, let me do it here.
First one's 9.
9 Suki.
All right. Mr. Carpenter says 9. All right, just a reminder, if there's no value in this little corner of the radical, make it's always going to be square root, all right? Here, you've got a cube root. All right, when we talked about this last week, this is, right? Negatives under the radical, when you've got an odd root, are solvable. So it's going to be a negative number, and the cube root of negative 343 is a negative 7. And while we're talking about that, let's do something here. All right, so if you don't have a TI 8384, hopefully you've got a calculator that does cube roots, fourth roots, fifth roots, sixth roots, all right? But you do need a calculator that does that. And you actually got a letter clear back in July saying that an 83 or 84 was required for this Algebra 2 class. And so here's where it comes into play. So if you want to do roots other than square roots, let's see here. Let me get this for you. Just hit the math key, which is right here, okay? And if you look down at about number, sorry about that, math key. If you look down at number 5, well, if you look at number 4, there's your cube root one right there. So just type on number 4, that's for cube roots. If you look at number 5, you can do any root. You can change, you can put any value you want under the radical, and you can put any root there that you want, 5th, 6th, 7th, 8th, 9th, 10th, and so on. If you've got a calculator that's not an TI 83 or 84, you've got some strange model and you don't have the paperwork for it, just go to YouTube and then just type in calculating roots on whatever your model is, TIX 871245, whatever it is. And most likely there's probably going to be a video there that'll step you through it. But you're going to need this because you're going to need this for one, this problem set and the next one, and you're going to need it for the quiz on this on Thursday. Any questions on that? That make sense? All right, where'd that thing go? Okay. All right, so let's see. So we did that one. So now we're over to 1. Everybody can see my screen okay? All right, so you can use your calculator for part of this. So again, it's a square root because there's no value right here. So the square root of 144, either looking off your cheat sheet or using your calculator, is 12, right? So we've got the square root of p to the 6th. There's a couple different ways to look at it. Remember when we had something like a squared to, and then parentheses into the 4th power? To simplify that, we actually multiply, when the kind of the exponents had exponents, that equals a to the 8th, right? All right, so now with roots, instead of multiplying, what would make sense is we're going to divide. So the 6th power to the 2nd root is p to the 3rd. Or that's one way to calculate, which is the easiest, because that's kind of the mathematical way. Or you could look at, okay, p to the 6th is p cubed squared. P to the 6th, does that make sense? P to the 6th equals p cubed times p cubed, right? Which is the same as p cubed squared, all right? So that would come out as 12p to the 3rd. Does that make sense? All right, I assume everybody agrees then. All right, the plus or minus outside the radicals, just to throw you a little bit of a curveball, doesn't mean a thing. All right, so the 4 comes out as a 2, and a to the 10th would be just using that same principle. The 10th power divided by the 2nd root is a to the 5th. Again, stop me if something doesn't make sense. All right, the 5th power. So we know this is going to come out as an odd number because this is an odd number, right? There's no way it could be an even number. If you put 240, you can't put this whole thing into the calculator, but you can put the numerical value in. So 243 to the 5th power is actually equal to 3. Okay? P to the 10th, 10 divided by 5 is now p squared, because that's the same as p squared to the 5th power. Keep going. All right, hearing nothing. The negative just is outside the radical, just stays as is. All right, so the third root of m to the 6th, 6 divided by 3 is 2. 9 divided by 3 is 3. Or you could look at this as n cubed times n cubed times n cubed, and to take the third root of that would come out as n to the 3. That's another way to look at it if you're kind of more into the mental math. If you're more into the kind of the manual math, 9 divided by 3. Any questions on those? Is everybody sleeping or what? Is anybody out there? Or am I just talking to myself?
We're here.
Sir, silly sir. You know we're here.
Okay, I was starting to feel lonely.
Suki, we're always here for you.
Boston burrito.
Okay, thank you, Mr. Neighbors. Get some new material. All right, we got a
Mr. Neighbors.
cube root and we got a negative under the radical. That is doable. So the negative comes out. All right, easy way. 12 divided by 3 is 4. All right. Or that's the same as b to the 4th times b to the 4th times b to the 4th. All right, so we know this is squared, so the 16 comes out as 4. 10 divided by 2 is 5. And this keeps it real simple. Sorry for the messy handwriting. All right, and b to the 8th comes out as b to the 4th, because it's the same as b to the 4th times b to the 4th. Let me keep going. 121, square root of 121 is 11. 6 divided by 2 is x to the 3rd power. All right, a little bit of a curveball here. We got 4k to the 4th and the square root of that, all right? So that's the same as 4k times 4k times 4k times 4k, right? So that's actually going to come out as, make sure we keep the parentheses. Don't fall into this trap, particularly in standardized tests. It's 4k parentheses squared, which is a correct answer, but a more correct and final answer is 16k squared. Everybody get that one? All right. Hearing no complaints, whining, or Boston burritos, we'll keep moving. The plus or minus, we don't touch. We just, or we do touch. Just read it as written. There's no influence by the radical. The 169
I
radical
love it, sir.
comes out as 13. 4 divided by 2 is r squared. Plus or minus 13 r squared. All right. All right, so we got a cube root. We got a negative outside. We got a negative inside. So this is solvable since we have an odd root, all right? So the cube root of negative 27 is a negative 3. And so now I've got a negative 3 times a negative. So now it becomes a positive 3. 6 divided by 3 is 2. And we're done. Any questions on those? Are we all getting these? We're getting these answers.
Or straight hundreds.
Or you just copying my word? Okay.
Sir, I see my work.
All right, the negatives outside the radical just carries on. All right, so we're taking the square root of 625. You're gonna have to pop that one into your calculator. If you didn't know it off the top of your head, that's 25. Y squared divided by, let's see, 2 divided by 2 is 1, right? Because this is a 2 here, right? So that just comes out as y. And the z to the 4 divided by 2 is 2, right? Negative 25 yz squared. 36 comes out as 6. Q to the 34 is 34 divided by 2, which is 17. It comes out as 10. The x squared comes out as x. Y to the 4th is the same as y squared times y squared, or 4 divided by 2 is 2. And the z comes out as to the 3rd power. Pretty straightforward. All right, this is doable because we got an odd root and we got a negative. If it was an even root, this would be no solution, right? No solution. Everybody understand? All right, so this comes out as a negative, and it is a negative, oh, that's probably one you're going to need your calculator for. No, it's something 3, but what decimal it is may be a little bit tricky. All right, so we got 36. We've done 36 before, so we know that's going to come out as, where was I? Oh, as 6, right? But this is a square root. Anything I need to be leery of here? Are we thinking? No solution. Why? Because there's no way I can get an answer, an even root with a negative under the radical. Just like I can never multiply two numbers that are either positive or two numbers that are negative and get a negative answer. So don't fall for that trap. Particularly watch out for that on standardized tests. I cannot, this would be also true if this was a 4, a 6, an 8, 10, or 12. Any questions or comments on that? Be careful out on standardized tests. All right, number 18. We've done that one before, or we know 64, so it's 0.8. And 10 divided by 2 is 5. 0.8 to the 5th, or 0.8 p to the 5th. We're going to put a 0 there. That would be nice also. All right, we got to the 4th root. All right, so we got 2x to the 8th. So this comes out as, this is kind of like that one that was, what, about 4 above us. Be careful this parentheses here, because that 8th power applies not only to the x, but to the 2. So it comes out as 2x squared, right? 8 divided by 4 is 2, which is you're halfway home to solving. You're not completely home. 2 squared is 4. X times x is x squared. You see the parentheses disappear. Let's see here. So now we've got, let's address this one way. Let's do this. So we know this is taking the square root. So we've got, let's see how we want to do this. 11y squared times 11y squared times 11y squared times 11. So, okay. So we got 11y squared times itself 4 times, right? So let's simplify things. So that comes out as, let's see, what's the best way to explain this? Let's do this. Let's do it. I'm trying to think of it. So this would come out as 11. Disregard my radical there. I don't want to go up and erase everything. This would come out as 11y squared. This comes out for one of the radicals, 11y squared and squared, right? Everybody agree with that? Disregard this stuff here. It's 11y squared to the squared because we just did, the 4 divided by 2 is 2. Now we're not completely done. Be careful with these parentheses because that applies not only to the y squared, but to the 11. So to take this to the final step, your final answer is 121 y to the 4th. Does that make sense? And did you get that? That one's a little tricky. If you got that one, you've got this mastered. That one you had to think a little bit. Okay, if I apply kind of the same methodologies to 21 as I did to 20, this comes out from another radical as, let's see, it'd be 5a, and my finger mouse is not working very good. Let's see, 5a squared b to the squared, all right? Everybody read that as 5a squared b, and then everything in parentheses. This is a parentheses here. All right, so to simplify that, the 5 squared is 25, right? And the a squared, this is a 2 here, kind of got lost in the scribble. all right, becomes a to the fourth. And the b to the first times squared is b squared. So that your final answer should be 25 a to the fourth b squared. All right, questions, confusion, anything I can eliminate? Fair enough.
Sir, can we go back to number 2?
Number 2, yeah. Let me clear my screen. Clear all.
That was no solution. How,
Oh,
is it because
so number 2 is solvable because I've got an odd root and I got a negative underneath. So I know my answer is going to be negative. So you're just taking the cube root of 343. Now that's kind of a weird root, and you're going to have to really, the best thing is just use your calculator to solve that. And it actually came out, wasn't it 7? I believe, yeah, 7. So -7. Let's look at this. Then let's look at it going the other direction. -7 to the third power equals -343. And you ask why? Because -7 times -7 is a 49, right? And then
yes, sir.
-7 times 49 gives you now that -343. All right. Any other questions?
Thank you, sir.
All righty, no problem. Okay, let me erase the board. All right. Let's see. I got to stop share because I got to change something up on you. All right. Let's see. We went 6-4, number 2. Bear with me one second. 6-4, number 2. Okay. Is that right? That's what I want. Okay. Throw that one away. Watch that one. Okay. Can everybody see this? It's problem set 6-4, number 2, and I put it in Blackboard for your class about an hour ago, a little bit before class. Okay. The good news is this, let me see, let me just double check. This whole problem set's done with your calculator. This whole problem set's done with your calculator. Everybody's got a calculator that will do roots in addition to square roots and cube roots, the most common ones, right? Calculator. All right, because that's strictly what we're going to do here. So that's one thing. You got to have a calculator that does roots in addition to squares and cube roots. All right. We are going to round everything to 3 decimal places. So let's talk about that because we always seem to have a problem with rounding. If you happen to have a calculator handy, let me just see something here real quick. Let's see, we did the 5th.
Suki, I have to go.
Okay, we'll see you.
All right. Thank you.
All right.
Fellow Boston burrito gone.
Okay, now, if you've got a calculator and you put this in your calculator and take the 5th root of 18.2, you are going to get an answer of 1.7 8654. 865 and that's enough. All right. Pay attention on this if you're not real good at rounding. All right, we are going to round to 3 decimal places. All right, 3 decimal places is we count from the decimal point to the right. That's 3 decimal places in this red box. Well, okay, 3 decimal places. All right, I want you to know how to round correctly because you're going to probably do some of this on standardized tests. to round correctly, you look at where you are lopping off part of the number. This is the key number, all right? If this first number that you're removing and everything to the right of it is 5 or greater, you're going to raise this number up by 1. If this number is 0 to 4, this 6 is going to stay exactly as written. I'm going to repeat it again just to make sure everybody understands, because you'll see some of this on standardized tests, SATs, ACTs, PSATs. We're rounding to 3 decimal places. So the key number is that value in the 4th decimal place. If this number is 0 to 4, you just lop everything off to the right of 4 decimal places. That's 4 decimal places, and the 6 stands as written. If this 4th number is 5, 6, 7, 8, or 9, the 6 is rounded up to 7. Everybody clear on that? All right. You got to know that because you'll do some rounding, particularly also when you go into pre-cal and calculus. Okay. All right, we're going to go back to an oldie but goodie. Remember the irrational numbers? Remember the P's and the Q's and the W's and the Z's and the N's and the I's and all that stuff? All right. If you go back to the archives of your brain, the irrational numbers were numbers that either repeated, like this guy right here, or did not terminate, like pi, which was, pi is what, I forget what it is. It's like 3.14157, something like that. All right. So we're going to be dealing with these irrational numbers. They're not going to terminate, or they're going to be repeating. All right. So just a little refresher there on that. Let's see here. Let me just. So rational numbers terminate. Let's see. Yeah, rational numbers terminate, and they also repeat. And if you ever see, it's kind of lost in the graphics here. But to express a repeating number, you draw a line over what keeps repeating, just like in this 17171717. All right. So it says radicals such as the square root of 2 and the square root of 3 are examples of irrational numbers, because if you plug those into your calculator, it's going to keep on going, right? Decimal approximations or proper rounding for irrational numbers are often used in applications, which is what we're going to do today, all right? These approximations can easily be found, or about the only way they can be found is with a calculator. So you're going to need a calculator. So this is pretty straightforward. You're just going to plug these values into your calculator, all right? And if you plug this into, let me just real quickly. All right, so if I plug 62 into my calculator and take the square root, I get 7.874. What else do we have? 0, 0. 0, 0, doesn't really matter after that. This is the answer I'm looking for. This is 3 decimal places, all right? This is a 0, so I don't change the 4 at all. If this happened to be a 5 through 9, the 4 will become 5. But as long as this number here, this first one where you are rounding, the first one to be removed, if it's between 0 and 4, that third value, that third decimal place stays as is. Any clarification I can do on that? Does that make sense? All right, likewise, let's see, second. All right, so like this one here, if I take the square root of 10,050, I get 32.4037.
Sir, was 6-4 problem set 1 due?
641. Yeah, I believe I had a drop box for that, didn't I? Yes, there was a drop box for it. I recall.
Yeah, I'm gonna go turn it because I don't think that I did.
Let me see if I believe I did. I don't have my notes here. I know 523B was a Dropbox. Some of you didn't do that one. I'll have to go back and look at 6.4, number one. I can't recall. Okay, so so here's the answer for this one, all right? So in this case, to round to 3 decimal places, all right, this first number being removed is 7, so it's greater than 5. So your right answer is you've got to change, you've got to raise that 3 to a 4. Okay? All right. Now, I can do more and more, but, you know, it's just a matter of plugging it into your calculator and go from there. The problem set's in your, there's no Dropbox for it, but it's under 4 CLD 428. So you can download it, or I can just scroll it up and you can copy these down. You can do that. You do not need to put it in Dropbox, but we'll go over it on first thing on Thursday. And then I'm going to give you probably about a 15-question quiz. Be probably 6 or 8 of like we just did on the previous problem set, and then about 6 or 8 of these.
So we don't turn this in on Dropbox. Just don't turn it at all.
No, sir.
Got it.
All right, let me just scroll.
Sir, wait. Why don't we just do it for ourselves?
You do it for the practice and preparation of for the quiz
Quiz.
and for
All right, Suki.
general knowledge. All right, this is what it looks like. Let me see. Let me look at my answers here and see if there's any other quirks that I need to enlighten you on. Let's see. Is anybody going to have difficulties if you look on the back side here? You got some strange ones. You got here sixth root. Here's a 4th root. Everybody got calculators that can do those? 6th root. I think even your phone, you got iPhone will do those type roots, which you couldn't do here at school, but you can do at home. Let me see if there's anything else. Now, there's a couple word problems which you may see as a bonus, which means you've got a word problem that follows a series of kind of mundane, generic questions. You're going to apply the same methodologies that you did in the previous questions. It's just you've got to kind of pull out of the problem what you're being asked to solve. But you're going to take a root of something. Okay. All right. Questions? Confusion?
Sir, was 5-2 problem set 3? Was that due?
Yeah, 523B was graded. And
Can you see if I turned that in? Because I'm pretty sure I did.
when I graded it over the weekend, I did not have one for you. There was only about 10 of you did it out of the 22.
All right, and now it's problem set. Which one again? 5-2.
Actually, you had a Dropbox for 523B and 523A. 523 on last what was it, Thursday.
What? Can you just tell me like the dates on them so I could like go back and look? Because I've been doing them, like, I've been doing some of them.
523B, 523B, I think we did on 421 or 423, and 523A we did on 4/9, which is before the Easter break.
Okay.
523A and 523B. If you want credits for those, I'll take them through tonight. But then after that, I'm not going back into old stuff. If you didn't do the quizzes, guys, get that to the 5-2 quiz. Get that to me today, because after today, I'm not going to take any more late work from chapters 5 and younger.
Sir, I just emailed you it.
Okay. All right. So here's just to repeat. Finish up this problem set for Thursday, and we'll just talk. I'll probably just do an answer key and just show you all the answers kind of simultaneously instead of me trying to write them. You can just check your answers. We're going to start 6.5, which is more stuff with exponents and roots, just a little more complex. And I will also then post a quiz for 6.2 question 6-4 online, and I'll probably just do a short class on Thursday and give you class time to actually do the quiz. All right. Questions, comments, concerns? Anybody lost? Anybody need help? I still do office hours every day, 2 to 2:30, Fridays 9 to 10. If you want outside consultation, all right, or assistance or aid. And that's all I've got for you, unless you guys got anything you want to talk about. We'll start 6 on Tuesday. We go over this problem set on from today. We'll do that first thing. I'll load up the quiz, and you just need to take it by Friday evening. If you want to clear up any of those zeros from the late work, make sure you get them to me today.
Are we good to leave, Suki?
523A and 523B.
You save for missing any homework or something?
No, you check Blackbot.
Are we good to leave, Suki?
Not just yet. Any last minute questions? All right. We will see you on, if hearing none, we will see you on Thursday at 1 o'clock. Okay?
Bye, Suki.
All right, we'll see you.
Sir, can I do my thing now? Just check in.
Let's see. Didn't we already do,
Instead of wait for like 20 minutes.
didn't you do it yesterday?
No.
You didn't do it yesterday? Let me set up an office hours thing here real quick. Let's see. Where can I put that? I'll put it right here. Neighbors. I gotta remember that. You get the 2-for-1 special.
I do, sir.
Let me, so that's, let me put it on the finance one also.
So finance, I already took the quiz. When we had like 30 minutes to take, I took that. And then I turned my quiz. I just emailed my quiz like 10, 20 minutes ago for math that I was missing.
Okay. I can see if, let me see something. Let me see if you want to know what, okay, so with that, let's do this. I can probably tell you what you got. Let me check.
Doesn't matter, sir.
Huh?
Doesn't matter.
It'll just take, I'm 20 seconds away from getting in there.
All right, sir.
Let's see. Got to figure it out. Dashboard. Let's see, chapter 6 quiz, right? Student view. Rats, why didn't they give it to me? Grade book. Oh, maybe it's under content. Why is it giving me that grade book? Hey, I'm sorry. I thought I could pull it up real quick, but I'm not coming up.
It's okay, sir.
All right.
Thank you, sir.
All right. We'll see you Thursday.
Thursday. Thank
Okay.
you.
Take care. Bye-bye.
Yes, sir.